Typically, an explore phase is anywhere from 15 to 30 minutes, depending on the magnitude of the problem. But for this particular problem, 15 to 20 minutes is usually enough time for them to get through Part D, which is where I can start thinking about what they want to summarize. I'm going to be circulating around the classroom and making sure that they're lining up the angle ruler in the right location to actually get a measurement that's going to be relatively accurate. I'm going to look for, in this particular problem, more of what their thinking is behind it. Because it's more skill-based, getting their reasoning of how they decided to do something is going to require me questioning them. So that's when I'm going to pose questions, is how did you get that answer? What were you thinking about? Where did you line up the ruler to get that measurement? Well, the questions that I'm going to think about are going to be ones for kids that are struggling, like, did your answer really make sense? If you think about the benchmark angles that we worked on in this previous problem or in the 4 in a row game, how might those help you think about this? So I'm anticipating that some students would then pull out their work from the previous day's work to see, how does this make sense? For the kids that need the additional challenge, I may say, well, what if I asked you to measure a different angle and have a more complicated shape to just hand off to them to try out? I'm really going to pay special attention to the students that are struggling to see if I can partner them up with a peer that might be able to help them. I'm also going to be paying attention to, are they making sense of supplementary and complementary angles, especially when it's the protractor design in Part C. So I'm really looking to see, are they recognizing I'm measuring how this is moving from here to here rather than thinking of it as a fixed something. Students have, prior to CMP, used protractors where an angle seemed like a fixed something. It's just sitting there. How can I measure rotation on that? It's not moving. So they want to measure the lengths of the rays rather than thinking about, ooh, this is how it moves.